In this example, we're going to go ahead and find this indefinite integral. So it looks like we have the integral of a fraction here, 2 divided by, and our denominator is the square root of x times this quantity, x plus 4, and of course that's with respect to x. So if you'd like to give this a go on your own, go ahead and pause the video and try it, and come on back and we'll work it together. Okay, so as I look at this integrand function, it seems like I have a square root of x right here, and then my quantity x plus 4. Well, the square root of x is the only square root of x I see, so if I include that somehow in my u, then there doesn't appear to be another square root of x to cancel it with, unless I consider this x right here as the square root of x squared. Okay, well let's go ahead and consider that then. So let's say u equals the square root of x. So if that's the case, then du will equal 1 over 2 times the square root of x dx. And finally, solving for that dx right there, I'll multiply both sides by 2 times the square root of x. So I'll have 2 radical x du for that left side there. Okay, so let's go ahead and make some substitutions here and exchange this integral. Instead of having it in terms of x, let's go ahead and make it in terms of u's. Okay, so it'll be 2 over, and this square root of x is our u right there. And this x plus 4 ends up being then, so it'll be u squared plus 4, and the dx is twice the square root of x, but of course the square root of x is u du. Okay, so it looks like these u's can cancel, which appears pretty nice. And then this 2 times 2 is 4, which we could go ahead and bring out front as a constant. So when we rewrite this now, let's see what we have. We have this 4 out front times this integral, and it looks like du over u squared plus 4. Okay, well this isn't too bad, especially because this form right here takes on one of the forms of the integral rules that you typically see in the front cover of your calculus book, which, let me go ahead and write down real quick for you. So we have the integral of du over u squared plus a squared, and that's actually going to be 1 over a times arctangent, and that's where that guy is going to come into play, and then of u over a plus c. Okay, so looking at this value then, so we have this u squared plus 4, and this is u squared plus a squared. So if we match up this 4 with our a squared, it looks like our a is going to be 2, and of course the u that they're talking about in this form is just going to be the u we have here. Okay, so let's go ahead and write this all together now. So we have 4 times, and using this form, 1 over a is going to be 1 over 2 times the arctangent of, we have u over 2 plus c. Okay, so a couple of things we can do now. Let's go ahead and multiply our constants out front. So we have this 2 times the arctangent of, then of course our u we can grab from our substitution we made earlier is the square root of x. So the square root of x over 2 and then plus c. So that's going to be the indefinite integral, and we know it's indefinite. We have the plus c at the end, plus there were no limits of integration given to us. So it's 2 times the arctangent of the square root of x over 2, and that will be your integral right here.